Okay, here we are again with another math notes. This is section 3.2.2, using area models to multiply polynomials. The area of a rectangle can be written two different ways. It can be written as a product of its length and width, or as the sum of the areas of smaller rectangles. For example, the area of the shaded rectangle at the right can be written two ways, as x plus 4 times x plus 2, or as x squared plus 6x plus 8. If we fill in our little algebra tiles here, we know that these are all 1. If we were to look at this side, this would be x plus 2, which we've labeled as width, and this would be x plus 1, 2, 3, 4, x plus 4. And we multiply those together, we know that we get the inside, which is the area of this whole thing, which is x squared plus 1, 2, 3, 4, 5, 6x plus 8. And we have both of those ways written right there. An area model helps to organize the different terms that make up the product. For example, to multiply 2x plus 5 times x plus 3, an area model can be set up and completed as shown. Notice that each small part of the rectangle contains the product of its dimensions. So what do we mean by that? We mean that if we look at just, we do this in a different color, if we look at just this upper left corner here, there's a little rectangle there. And we can think of that as length times width, which would be 2x times x. And then inside this we would have 2x squared, because 2x times x is 2x squared. This upper right corner would be 5 times x, or 5x. The lower left corner would be 2x times 3, or 6x. And the lower right corner would be 5 times 3, or 15. So we have that all filled out here on the right. And again, if we think of it as length times width equals area, then we know that we're going to have our length here is 2x plus 5, our width is x plus 3, and our area, the inside, is all of that added up, which is 2x squared plus 5x plus 6x plus 15, and we can combine the 5x and 6x into 11x to get us 2x squared plus 11x plus 15. Note that while an area model helps organize the problem, its size and scale are not important. Some students find it helpful to write the dimensions on the rectangle twice, that is on all sides of the area model. So if you wanted to say this is x here because it's x over here, or 3 here because it's 3 over here, or 2x here, or 5 here, that might be helpful for you. So that's up to you. The advantage of that is you can see that this times this equals this. That times that equals that. So on and so forth. So if you want to do that, you can. On the next slide, guys, I've got some practice problems for you. I'm just going to make them up here. So create an area model, multiply these out, and write the product, or write the area as a product and a sum. So we're going to say 2x minus 1 times x plus 7. Let's say 3x minus 2 times 2x minus 6. And let's give you a little tricky one here. Not so tricky. X plus 7. I don't know why I like x plus 7 right now, but maybe I do. Times 2x. Let's do 2x squared plus x minus 3. Think about how you're going to represent that last one in an area model. Here's a hint. It may need to be a rectangle instead of a square. All right, I will see you guys on the next Math Notes.